Let's move on to topic C, modeling the data. Modeling the data not only includes building your machine learning model, but also selecting important features, columns that will go into your model. This selection will be divided into two parts, feature selection and model building. Before building our first machine learning model, we have to do some feature selection. Imagine a scenario where you have a large number of columns and you want to perform prediction. Not all the features will have an impact on your predicting model. Having irrelevant features can reduce the accuracy of your model, especially when using algorithms such as linear and logistic regression. The benefits of feature selection are as follows. It reduces training time. Fewer columns mean less data, which in turn makes the algorithm run quickly. It reduces overfitting. Removing irrelevant columns makes your algorithm less prone to noise, thereby reducing overfitting, and it improves the accuracy. It improves the accuracy of your machine learning model. Methods for selecting features are as follows. Univariate feature selection. This works by selecting the best feature based on the univariate statistical tests. It finds features that have the strongest relationship with the output variable. Recursive feature selection, and this works by recursively removing features and building a machine learning model based on the features remaining. It then uses the model's accuracy to find the combination of features that contribute most to predicting the target. Principal component analysis. Principal component analysis is a variable reduction procedure. It uses linear algebra to transform the data into a compressed form. And tree-based feature selection. Tree-based estimators such as random forest, bagging, and boosting can be used to compute feature importance, which in turn can be used to discard irrelevant features. And now it's time to do another exercise. In this exercise, we will be performing feature selection using a tree-based selection method that performs well on classification tasks. Ensure that you use the same notebook as the one used for the preceding exercise. First, we are going to import random forest classifier and train test split from the sklearn library. And now we are going to encode the categorical variable using the following code. Now it's time to split the data into training and testing sets. Let's go ahead and fit the model using the random forest classifier for feature selection. Please note that the random forest classifier is used here for feature selection, and it gives good results for classification-based problems. Now we are going to call the random forest feature importances attribute to find the important features and store it in a variable named importances. We are going to create a variable named features to store all the columns except the target variable churn. We also sorted the important features present in the importances variable using the NumPy argsort function. Now it's time to plot the important features obtained from the random forest using matplotlib's plt attribute. Now from the figure, you can see that the 5 most important features selected from the tree-based feature selection are age, estimated salary, credit score, balance, and number of products. This exercise was very important for you to understand the feature selection process. The next step in the awesome pipeline is to build a model. This includes trying out different kinds of algorithms to build our prediction model. Let's go and do an exercise about this. Hi everyone, and welcome to this exercise of building a logistic regression model. As a data scientist, you are able to help both your senior management and the marketing team to explain the key variables affecting customer churn. Through EDA, your marketing team understood the key reasons for customer churn. With their expectations very high, they want you to predict customer churn so that they can focus on customers who might churn. We will be using logistic regression as the base model for our churn prediction because of its easy interpretability. Now we will import the stats model package and select only the top 5 futures that we got from the previous exercise to fit our model. Stats Models is a Python module that provides classes and functions for the estimation of many different statistical models, as well as for conducting statistical tests and statistical data exploration. Once the model has been fitted, we're going to obtain the summary and our parameters. You should also get the same output that I got here. We're going to create a function to compute the coefficients. And we're also going to calculate the chance of a customer churning by inputting the following values: age 50, estimated salary 100,000, credit score 600, and balance 100,000. Also, number of products 2. Now our output is approximately 0.38, implying that a customer who is 50 years of age, having an estimated salary of $100,000, a credit score of 600, and balance of $100,000, and who has purchased 2 products would have a 38.23% of likelihood of churning. In the previous steps, we learned how to use the stats model package. In this step, we'll implement scikit-learn's logistic regression to build our classifier and predict on the test data to find out the accuracy of our model. We're going to fit the logistic regression model on the partitioned training data that was prepared previously. Let's call the predict and predict probe functions on the test data. Let's calculate the accuracy of our model by calling the score function. Note that we used LBFGS as an optimization algorithm that approximates Bjorden-Fletcher-Goldfarb-Shannon algorithm and is recommended for a smaller dataset. Congratulations! You have successfully implemented logistic regression using the stats model package. The coefficients of the regression model were obtained in step 2. The logistic regression equation was created in the step 3. And the probability for a customer to churn was calculated using the sigmoid function in step 4. Lastly, we used sklearn's logistic regression to predict our test data and scored an accuracy of 79%, which implied that our model was able to accurately predict 79% of the test data correctly. We will study more about how to check the accuracy of a model in the next lesson. The last part of our analysis is interpreting our data, which is summarizing the insights that we have obtained from our analysis. The number of customers that churned is 20.37%. That makes 2,037. And that number that did not churn out is 70.63%. Overall, the average credit score of customers who churned is 645.35, and the average age of the customers who churned is 44.83 years. The average balance and the estimated salary of the customers who churned are $911,108.53 and $101,465.67 respectively, which is greater than the customers who didn't churn. The median number of products purchased by customers who churned is 1. Customer age and churn are 29% positively correlated. Balance and churn are 12% positively correlated. Number of products and balance are 30% negatively correlated. The difference between churn and non-churn customers in Germany and Spain is less than in France. Comparatively, more female customers have churned. The amount of churn is greater for customers with 3 to 4 products. Customers within the 35 to 45 age group seem to churn more. As the age of customers increases, they usually churn more. The amount of churn is less with customers with a negative to low balance compared to customers having a balance of 75,000 to 150,000. The most important features selected from tree-based feature selection are age, estimated salary, credit score, balance, and number of products. We got all these results by getting the knowledge following our lessons. I hope you enjoyed this journey with me. Please keep watching.